Hi, welcome back to Intermediate Algebra. Today we are looking at section 5.3. We're going to be adding and subtracting rational expressions. So there's a lot of work that goes into this. This is, it's fractions with polynomials in them, and we're going to be adding and subtracting, so this can be a bit of a mess. So hang in there, go through this video a few times if you need to, and, just be really, really careful. So we're going to start by talking about the least common denominator. So, as you hopefully remember when adding fractions, let's ignore polynomials for just a second, but when adding fractions, you can only do that if the denominators match. So, for instance, if you had 1/2 and 3/4, the common denominator would be 4. And so we're going to be looking at this with now having rational expressions and polynomials running around everywhere, and we're going to be looking to find those common denominators when they're kind of ugly. So let's see, I've got some steps here, and then I have one little note that I want to look at, and then we'll look at actually finding some common denominators. So let's get started. Step 1, factor everything. And by everything, I'm really talking about the denominators here. Get all of your denominators factored as much as you can. This is going to be really important because it's going to allow you to see all the pieces that are making up your denominators, so you can build the smallest possible denominator that you can, which is going to be good because as we go through this, if you make your denominator too big, it's going to be really hard to work some of these problems. So we want to see all the pieces that we have. Step 2, we're going to use the most of each factor. So for instance, if you have an x and an x squared, those are really the same kind of thing, just x squared is 2 of the x's, whereas x is just 1. And then last but not least, number 3, multiply your factors together. So I do have a note here, and I kind of sort of mentioned it just a second ago too. X plus 3 squared is the same as x plus 3 times itself, x plus 3 times x plus 3, which means that this is really the same kind of thing as just a single x plus 3, but there are 2 of them. Okay, so it's the exact same kind of thing, there just happen to be 2 of them. Same thing with x squared. X squared is just x times x, and so it's really the same kind of thing, just with 2 of them instead of 1. And so that's going to be important as we start finding our common denominators. So let's go ahead and get some examples up on the board and look at common denominators. All right, so for starters, I have a couple of examples here that aren't really actually going to require any factoring. We'll get to those here in just a minute. So I wanted to start with just some nice numbers because I know that people really love fractions. So I thought we'd start with some numbers and get that out of the way, and then we'll move into something with some letters in it. So 5/6 plus 4/9. So we need a common denominator, and it's always worth remembering the least common denominator is always at least as big as the denominators you already have. So sometimes people will be like, ooh, 3, because 3 goes into 6 and 3 goes into 9. But it can't be smaller. Okay, it's always got to be bigger. So in this case, it is 18. 6 and 9 both go into 18, and so there we go. If all else fails, you could just multiply the 6 and the 9 together. You'd have some reducing to do, but you could do that. So anyway, I went with 18. So to get from 6 to 18, I need to multiply by 3. So I multiply top and bottom by 3, which gives me 15/18. For 4/9, 9 needs to be multiplied by 2, so I multiply both by 2 and get 8/18. And when I add, I get 23/18. And reduce your fractions if you can, but I am perfectly willing to work with improper fractions. I love 23/18. Great answer. All right, now for the one that actually has some letters in it, and then we'll get into the really fun stuff with some polynomials. 5/x minus 1/3. So if you go back and look at the directions that I gave you, you have to factor everything. Well, you can't factor x or 3, so we're done there. And then we need to use the most of each factor. So my pieces here are the x and the 3, which means my common denominator needs both of those. And so you'll notice that in this case, my common denominator is just both of them smashed together, 3x. So I can turn them both into 3x, like I did here, by multiplying, just like I did with the numbers back over here. So for 5/x, to get to 3x, I need to multiply that by 3. 5 times 3 then gives me 15/3x. For the 1/3, it's missing the x. That's what we need to multiply by to get to the 3x, so I do that. And again, I multiply both the top and the bottom by x, and I get x/3x. So now I have a common denominator, And as we know, once you have a common denominator, you add or subtract just the numerators, right? I didn't add the 18s back here. We don't do that. Just the numerators. So we get 15 minus x over 3x. You can't reduce that, so please don't try. But yeah, that one's done. So again, the important thing is we need to identify the pieces that make up our denominators, so then we can just smash them all together to make our common denominator. So let's look at one that's a little bit trickier. Okay, so I have two more examples here for you. 9 over x plus 7 over x squared. So importantly, the denominators here are obviously different, right? One is an x, one is an x squared. But here, they're made up of the same kinds of things, right? X squared, we talked about this a little bit earlier in the video, is just x times x. And in fact, I'll just go ahead and jot that down right here underneath so we can see it, right? X squared is just x times x. It's just 2 of the x's instead of 1. And so what that means is, remember how we said factor everything? So I really just did there. But then we only want to use the most of each factor. I don't want to use x and x squared. That would make x cubed, and that'd be okay, but it's going to make my life harder. I'd have reducing to do at the end, and later when we get into the equations, it's going to make equations that really we're not prepared to solve yet, so we have to be a little bit careful here. So what we can do, though, is say, okay, look, we want to use the most of each kind of piece. So when I look at this first fraction, it has just an x, it has one of them. The second fraction has x squared, it has 2 of them. 2 is more than 1, so we're going to just use two x's, x squared. Okay? Again, we don't need all 3, we need the most that show up in either fraction, in this case, x squared. So, my second fraction doesn't change at all. It's still just 7 over x squared, right? It already has the common denominator that I want. Now, for the first fraction, it only has x, so we need to multiply that denominator by x to get x squared. And if we multiply the denominator, we also have to multiply the numerator, giving us 9x over x squared. Now those denominators are the same. We go ahead, we just add them together. Again, 9x and 7, not like terms, can't actually put them together. But here we have it. We've taken our two fractions, we've put them together to make one fraction. Is it kind of funny looking? Yes, it still has addition in the numerator. It's really tempting to want to cross out one of those x's, but you can't because the addition in the middle. So this is actually our answer, 9x plus 7 over x squared, and that one's done. Now, for my other one, this one's a little bit bigger and messier. This one's actually going to really require some factoring. Not a lot, just a little bit. So we have 9 over x plus 6 plus 7 over x squared minus 36. Sorry, x squared minus 36. So I need to get some factoring done here, and if you don't remember how to factor, go way back in the course to the very first section that we did. I think it was section 1.5, but don't hold me to that. Anyway, so we need to factor this. X plus 6 does not factor, so I just left that alone for now. But you'll see that I took x squared minus 36 off to the side, and then I factored it. I recognize that it's a difference of squares, right? 36 is 6 to the second power. So it factors to be x plus 6 times x minus 6. Now, once I have it factored, I brought it back so I can see what it is I'm working with here. So I have 9 over x plus 6 plus 7 over this great big mess, x plus 6 times x minus 6. And the first thing that I notice is that these two denominators have something in common. They both have an x plus 6 piece. The difference is the second fraction also has an x minus 6. So now that we have it factored, remember, we just want to use the most of every piece that we have. We don't want any extras. That's really important. We don't want any extras. So when I look at this, I need the x minus 6 because there's one of them and I gotta have it. But for the x plus 6's, even though there are two separate ones here, one in each fraction, that important part is that there's only one in each fraction. And remember, we want the most of each piece that shows up. And so for the x plus 6, the most is still just 1 because there's 1 here, there's 1 there. The most is 1. So my common denominator is x plus 6 times x minus 6. Okay, just taking those two pieces and using them together. Now, that means that the second fraction, it already has the denominator that we need it to have, right? That matches. For the second one, it's just missing this x minus 6 piece, so I multiply by that. But I have to do it on both the top and the bottom. And we always, when we're changing these fractions so we can add and subtract them, we always multiply the top and the bottom by the same thing. So then you can see now we have a common denominator. So I go ahead and do the addition. Along the way, I kind of cheated a little bit because I was running out of word space. I multiplied this 9 times the parentheses, so I got 9x minus 54, and then the plus 7 from adding the fractions. Combine my like terms, negative 54 and 7 makes a negative 47. So my final answer is 9x minus 47 all over x plus 6 times x minus 6. And good news for you guys, I don't need you to multiply that out. So if you're watching this video because you're taking my class, don't worry about multiplying that denominator out. Just leave it factored. If you're not taking my class, well, who knows? Maybe if you're anyway. But I can only make promises about people in my class. So there you go. There are some examples. There's going to be a lot of factoring and a lot of piecing together these denominators. Once you do that, it's really kind of sort of straightforward, but it's a little bit weird still. So good luck. Do lots of problems to make sure you understand how to do this. Have a great day.